What happens here, what's going on when you're working with the law of sines or law of cosines and whatnot, cut the glare. What'll happen is when you draw it out, label it up, 10, 5, 25. Okay? Whenever you have to start with an angle and the side opposite it, you're going to use law of sines to start. Do you agree?
Yeah.
Okay. Cosines is for when you have the side angle side or side side side. In this case here, we have to cover our SSAs, if you will.
Thank you.
So when this happens and the given angle is acute, take a quick second and check, is the given angle, sine of 10, the side next to it, smaller than the side opposite?
Yes.
Okay? If it is, then you want to check and see if it's smaller than the other side as well. Remember, this generic formula of B sine of angle A smaller than B, those two values of A are just standing for the given angle and the side opposite. The B value fluctuates between whatever other side you've got. All right, so those values could change. When you check that out and you find that you have two possible triangles with the ambiguous case like that, what you want to do is immediately just solve for the next angle that you can find. In this example, what is the next angle that I can find?
C.
C. So when we solve up for C, sine of 10 is to 5, and sine of C is to 25. When you do that, I'm getting C is 60.25. That is one of the possible angles for C. Now, what happens here, and I really want you guys to try and remember this, is once you know that you've got two triangles that you're going to have to work with, immediately just go ahead and draw up, draw your two triangles and just start filling in what your possibilities are.
Oh my goodness.
So C is 60.25, B was 10, this is a 5, this is a 25. Now, the other possible value for C is what, Richie?
All this time I've been thinking that when you've been saying two triangles, I thought you meant there was a triangle inside of the triangle.
Yeah, I thought that was like one line. Like it was.
I didn't understand that.
No. What's happening here is that, and we kind of talked a little bit about this yesterday, is when we get into the unit circle, remember I kind of mentioned that it's going to go cosine, sine?
Yeah.
Angles that are between 90 or greater than 90 but less than 180 degrees, their sine value is positive. Same over here. If you happen to have an angle that was 60 1/4, there's what you would call a reference angle over here that bounces up from 180. That angle has a theta terminal side of, what was it, 119 or something? Yeah, 119.75. What this is happening is that the cosine and the sine values for these two angles, the cosine values numerically are going to be identical. The sine values will be the same. Cosines will just have different signs. The sine value, not S-I-N-E, S-I-G-N. Okay. That's why you're able to come up with two different triangles that has that same sine value, S-I-N-E. So you just draw them in. 119, 75, 10, and 5, 25. Now to find angle B, angle A in these guys, it's going to have a different angle. Subtract from 180 in both of them, and you're going to get a new angle A of, what is it, 109, 75, and over here it could be 50.25. And then you just use law of sines one more time to find that little a, that side value. Does that make sense? Yes, ma'am?
Can you explain how you got the 119.75 on the right?
That's how you get that. You're taking 180 degrees and you subtract the first angle that you found. Again, what's happening here, and I think a real easy thing to show you guys. In your calculator, what I want you to type in is the sine of 45 degrees. What do you get? Okay, let's do it with 60. Sorry, I'm trying to remember which one was the clean one. 60. Sine of 60 is 1/2, right?
No.
Sine of 30 is going to be 1/2. Let's try that one.
Yeah.
All right, I do third time's the charm.
Check.
So the sine of 30 is 1/2.
Yeah.
The other angle that has a sine of 1/2 means the y value would have to be the same coming over here. That means this angle here is 30. Now, if this is at 180 degrees, this coming up here is 30, how much is it going this way? 150. What you're doing here is we're using a definition of something we haven't quite yet defined. We're using what's called a reference angle. We're finding another angle that has the same trig value in a different quadrant. Okay? So values of sine, when you're using law of sines, you could have an angle that is between 0 and 90, or between 90 and 180 that has the exact same value. Same thing is going to happen if we look at cosines. We're not doing anything like this with cosines, but your cosine values are both positive in the first and the fourth quadrant. So you can have an angle that's 290 degrees that has the same cosine value as an angle that is in the first quadrant. Yeah.
Two questions. Can you have two triangles when it's 90 degrees?
No, because when you get the 90-degree triangle, you're going to use right triangle straight. You're not going to have to worry about that.
And then second question, do you only go to look at those two triangles if it's angle and then you have one of the adjacent sides and then the
Yeah,
opposite?
you look at it, you're
Only if
basically,
it's those like
you're
SSA.
covering your SSA. Okay. And also, if you did use the B side A, if it equaled A, it is a right triangle. You're only going to get one triangle for that.
But if it equals it, oh,
You see what I'm saying? That's kind of reference to your first question. All right, so you don't have to worry so much about that. So again, in order to find that second angle, it's basically telling you that you're going to either have an acute angle or an obtuse angle that has the same sine value, and you just draw two triangles to finish it out. Okay? I've got another ambiguous style here we'll try in a second. Okay? Yes, sir.
So you said we only do this with SSA, not SSS or SAS?
What happens when you're doing the law of cosines? To scare you here. If you get an acute angle, take a quick second just to verify it might not be 2. It does from time to time show up. I don't think any of our problems did, but it's not to say that it couldn't. Okay. What else want to look at? You just want to do another ambiguous one?
yeah,
Why is Huntington
That was the answer to the trivia question this morning. Which one? I told you how to do 50.
50 was pretty easy.
What's 8 plus 5?
13.
What's 12 plus 5?
17.
Okay, so you have a side of 17 and a side of 13.
Law cosine.
Log cosine.
It tells you that with the arrows.
Yeah.
Oh my goodness.
26 squared is 17 squared plus 13 squared minus 2 times 17, 13 cosine theta. Silly theta.
anyways, that's what you're trying to solve. Okay.
Yeah. So let's see, 26 squared minus 17 squared minus 13 squared
119
divided by parentheses negative 2 times 17 times 13 inverse cosine of the answer. I did it wrong. Womp, 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 womp. Oh, I just cosine the answer.
Oh, wow.
I know.
Perfect.
119.55.
That's what I get.
That's what I get.
That's what I get.
Okay.
That's
Again.
what I am.
Silly buttons. All right.
Except for buttons.
Want to look at another ambiguous?
No.
Ambiguous.
What does ambiguous mean?
I have Fisher and
It's the weird case. What's
When
that?
it, when it comes to triangles?
Yeah, we're just gonna look at a bunch of stuff today. I want to try and do a couple extra problems here and there. I want to make sure you guys understand how you set up, even if you're using, bless you, when you're using law of cosines, just to quickly check to make sure that the triangle doesn't have two of them. It could.
Well, I like know how to do it now, and notice that I just don't remember like the test. Like, I don't remember how to do it.
Of the,
Of that's two triangles, like,
Yeah.
what you want to remember, really all you have to remember for the two triangle stuff is angle, or B sine A less than A. All of that is that I'm writing that out as B, oops. And I was showing people this earlier. This is just the angle and side opposite. These two are just the other side. Okay. It's going to look like a side-side angle case. All right. It's going to look like a side-side angle on that one. Usually, what happens if you're given two angles right off the bat, you're going to be okay. All right. It's the side-side angle one is usually the one you have to pay close attention to.
That's trippy, man.
I'm trying to think if there's another weird one in here from last night. I don't think any of the other. I don't think that was the only one that had the weirdness to it. Let me show you guys another one that I know is weird. Just forgot which number it was. All right.
Probably with it.
I forget which one went with what.
I don't remember.
So let's take a look at this one again. What's up?
So,
No. What's that?
okay, like on question 35 in the homework,
Yeah.
when I subtracted to find the cosine, to find angle B, I got a negative number, but then somehow I still got the right answer. Like I still like figure out the answer, I don't know if it's right or not.
What'd you get for B?
Or not.
81.4.
I'll do that one.
Okay,
I'll go back to that one after this.
Yeah, it's still worked out. It's just
You turn that on.
Wait, what was your?
Let's try this other one real fast for you, then I'll come back to that one, okay?
okay.
All right. So let's walk through this one again together, see how we set this one up.
Numero.
This isn't a numero. This is one
This is
minute.
a Murph question.
Ambiguous.
Wait, is that 2.20?
So ambiguous is if you don't know how many
Let's
triangles
see.
there are.
Right.
Okay, fair enough.
Again, this is a case of that side-side angle where I'm given an angle and the side opposite. The angle that I'm given is acute, so I'm going to check and see if it falls into that realm. So I take the side next to it, sine of 70. Is it less than 155? And is that less than 160? One quick thing you might notice right away, see how this is already true? And the problem we had a second ago, it was true as well. It's probably already going to tell you that when it was true. Is it true?
150.5.
Yeah. Okay. So in this case, again, you're going to get two triangles when you work it out. So what's the first angle you're going to solve for in this case? I agree. I'm going to solve for angle C. The reason I'm going to solve for angle C is because I know the side opposite. Yes.
Can you like draw out the second one?
Yeah.
Do you
I'm gonna keep angle A and the side opposite it the same value. Is that what you're asking?
No, like, I was separate triangle. Like, on the first triangle, you have that.
Reuse 70?
No, you use,
Oh, the reference part? No, I'm gonna reuse. Yes, I'm gonna switch that up with angle. Once I find out what angle C is, then I'll get the reference angle and mess around with it. This is only for finding that second angle. Here you're just gonna have A, and little a is always gonna be the same. Little c is always gonna be the same. So when you set this through, you got sine 70. Give me a second, Hunter. So 155 sine of c is to 160. Now, are we at the point where I don't have to show you guys all the cross multiplying here?
Yeah.
I'm hoping?
Yeah.
All right.
it's 75.93.
On your FM dial? Thank you. It's just, yeah, it did.
No, what is it?
That's what
That's what you said.
So we know that we're going to have this or 180 minus that.
That's pretty good.
104.07. Everybody okay with that? Now you use your two triangles then. We were 70, 155, 160, 75, 93.
Can you make that a bigger C just to stop confusion?
What's that?
Can you make that a bigger C for following?
Sure. Remember, I really don't care that if it's drawn to scale because I'm just using this so I know which parts I'm left with finding out. That's all. I mean, if you want to try and draw it out to make it look more accurate, go for it.
Yeah.
It doesn't. It really isn't that big of a. It really isn't that big of a deal here. So does everybody agree? Yes, sir.
On the test, can we round the whole numbers?
2 decimals. Try and keep everything standardized as 2 decimal places. It's a very common thing throughout this book, and it's kind of how I've always do all of it. So unless I ask you to leave in your answers in terms of pi, then we'll worry about that later. For the triangle on the left, then, what do you get for angle B? Okay. So then when you do the law of sines, sine of 70 is to 155. Sine of 34.07 is to B. Over here, what was little b? 593.
it's small.
Okay. And that's how you're going to wind up with both your values. Yes, ma'am.
So the only thing that stays the same between the two triangles we get.
Correct. Yep. Your givens are always going to be the same. It's just that once you find out that you're going to have 2 triangles, you're going to get the acute angle and the obtuse angle, and you just change it all out. Yeah.
Quick question about figuring out if it's two triangles. Say if the little a was 160 and if the little b was 155, would you know anything to show you?
If little a,
So like if you swap the 155 and 160.
you swap those around, it might not work then. Because then you're saying that 160 is across from the 70, and then the
But do you know anything directly like a like corresponding to a and b, or is that only actually? Like
that's
the-
all. Yeah, I see what you're saying. Yeah, that's only really with the obtuse stuff is that you know definite with definitive answer that it'll work. What he's getting at here, guys, is when you have the obtuse angle, it's pretty blatantly obvious of when you're only going to have no triangle. Example: if I say that I have angle A is 95, little a is 12, and little b is 15. Can any other angle within the triangle be larger than 95?
No.
No. Okay. So, can I have a triangle here? No. It's really that quick to be able to tell when that happens. All right. Morgan, you wanted to look at 35, correct?
Yes.
Okay, so let's look at 35.
I was something on this one, but whatever. So I mean, I think I know the other one's right, so.
Which angle did you go for first?
Angle B.
Okay, right. Well, you started with the correct angle. All right, so let's see. A, B, and C. 51, 36, 48. Now again, the reason I always want to try to find the largest angle first is because I might find an obtuse angle and I'll be set. If I find the really small angle first, I could have to worry about the two triangle scenarios. So you still might have to worry about it, but you run into less of an issue. So we start with angle B. So let's see here. 51 squared is 36 squared plus 48 squared minus 2 times 36, 48 cosine of B. One squared minus 36 squared minus 48 squared. I remember you had that.
Yeah.
Okay. Divided by parentheses, negative 2 times 36 times 48. You get the negative 2?
I got that. And then you do like,
73.2, would I round out?
yeah, all right, I get it. I don't know what happened when I did. I
It's-
probably typed in something wrong or something.
You might have hit just cosine of the answer.
Yeah.
You might have just done something like that.
Maybe
Yeah, it's very, very easy to do something silly. Okay.
All right.
So 73.2. Is that angle acute? Yeah, check it real quick. Check and see if it's going to work with one triangle, two triangles, just to be on the safe side. Does it matter which side you choose? All right, we'll use 36. 36 sine 73.2. Is that smaller than 51? It's okay, but is 51 smaller than 36? No, so I know it's not. I know we'll be all right. Okay. Notice how if I would have put the 48 here then as well, the 48 here, it's still that wouldn't have held true. So you wind up over time you might start to pick up how this works out. Yeah.
So if on the test I put the wrong one with the number, if I put the number with the wrong letter, but I still came out with the right numbers, would that would you penalize me? Because I switched the 51 with the 36.
Oh,
but
when
I
you
still
first
got the-
labeled it out,
Yeah, but I still got the right numbers. It was just like the wrong letters.
did you draw a diagram?
Yeah.
Then I would be able to figure that out. I would have been able to figure out what you did because you drew the diagram. And that's the whole idea. If you draw your diagram and you put them in the wrong value, you're going to get the wrong right answer, if that makes sense.
Yeah.
So as long as you're visual with it and I can figure out where you went instead of just going right to your calculator and just trying to go for it, which I know a lot of people can do this right off the calculator, you'll be better off. Okay. So, but that's fine. That's fine. Did you want me to continue the morning or are you all right? Remember, once you get one of them, it just falls right into the law of sines. Okay? You can just use law of sines out of there. Questions? Yes, sir.
Could I get the worksheet?
Yeah, that's right. The other thing in this section is one last formula. It's called Heron's formula. It's another way to solve for the area of a triangle when you're given just the three sides. And it's a very, very easy thing to do. 8 through 16. All right? What's that? No, I don't care. All right. This formula is kind of weird. We've already talked about another formula for finding the area of side angle side.
Yeah.
And we've already talked about how to do side angle side with the area formula, and it was very, very easy. This is another one, it just looks a lot weirder. What they're talking about is something called a semi-perimeter. What is a semicircle?
3/4.
Half of a circle. So what do you think semi-perimeter would be?
Half the perimeter.
All right, half the, Richard, that's enough. That's enough. So if you have 3 sides of a triangle, how do you find its perimeter?
Divide into 2 triangles.
What do we do?
No, I was gonna say, can you make it bigger? Thank you.
Here's what happens. It's a very, very extremely straightforward formula. It's going to take about 30 seconds for you guys to figure this out. Say we have A is 15, B is 20, and C is 25. Those are 3 side lengths of a triangle. I don't care about the angle measurements. I'm not going to draw it out. I'm not going to try and draw an altitude, figure out some law signs, draw a right triangle, which I know you guys know how to do because I think I've seen you try to do that with some problems. What we can do here is the following. We find this value S, which is basically add up the sides and cut it in half. So what's 60 divided by 2? 30. Now the easy part. In your calculator, you do this. You hit the button that says square root 30 times 30 minus 15. Parentheses 30 minus 20. 30 minus 25. And you hit enter. And lo and behold, it spits out your answer. And that's the area of the triangle. It's that fast. Square root 30 parentheses 30 minus 15, close it, open it. 30 minus 20, close it, open it. 30 minus 25, close it, hit enter. 150. Make sure you label it. Okay? It's really that fast. Excuse me. When you do these things, you're adding up all your sides, cut it in half, and then doing that pattern with it. It's very fast. There's not a lot of scariness involved here. It looked a lot worse than what it is. All right? Do you agree? Try one more, and I'll give you some problems. That way you guys get extra questions. Find the area of that, please. What'd you get? 427 something? Make sure you label it. Not too bad, is it? Confident? You guys will be fine. I think the quiz is 7 questions. 8. You have 42 minutes to do it. I think you're going to have plenty of time. Yes, sir.
And they mostly solve the triangle.
Solve the triangle. Yeah, it's basically solve the triangle. I think there's about 1 problem per style that we've done the entire 3 sections here. All right. Okay. Let me give you some problems to try out, and if you got questions, we'll just wander through them together.